our new Virtual Science Center channel where you can check out content every day at 10:30 and at 3 o'clock, because even though the Science Center is currently closed for the health, safety, and wellness of our guests and our staff, we are still going to bring you science every single day. So today we are going to be talking about solids, liquids, and gases. But before I get into that, my name is Joy. Now we talk about solids, liquids, and gases. So I have here my solid super science orb, and I want to study it closely. So I'm going to put it into this container. It's fine, everything's fine. Just need to crush it. It's not gonna fit. It's fine, I just didn't crush it enough. I'm okay. Now I'm finished. Okay. It's not working. See, what do you think at home? Why isn't this working? I think it's because this container, the opening of this container up here at the neck, is way too small to fit this science orb. Because solids keep their shape. I can try to crush this as many times as I want to. I'm not going to be able to make it fit into this container because it's a solid. Solids don't just arbitrarily shrink and completely change based on whatever container they're in. Now, liquids take the shape of their container, and they also pour pretty well. So I have here some liquid in my magic beaker. This is kind of a cone shape. Now this looks clear, it looks a lot like water, but we are going to see what happens if I pour it into some of these beakers, because I'm not really a clear person. I kind of like colors, if you couldn't tell by the rainbow lab coat, it's more my style. So let's see what happens when we pour this clear liquid into the beakers. Here we go. What? It is red. Let's see what happens with this one. We got orange. And we got green. And purple. Now, if you notice, this all looks very different, not just color, but it's a different shape now because liquid takes the shape of its container, but also it changed colors. Now notice, I didn't tell you what was inside of my magic beaker. I just said it looks like water. It is actually not. It is something called a base, specifically sodium hydroxide, for those of you that like chemistry. Now, inside of each of these smaller beakers is a pH indicator. And what a pH indicator does is it changes colors when it comes into contact with a base. So when I poured this liquid into each of these beakers, it changed a different color because of the specific chemical and pH indicator that was in there. So we've talked about solids that keep their shape, and we've talked about liquids that take the shape of their container. So let's see, does anyone remember what's left? Solids, liquids, gas. So I have here a bucket. Let me get this out of the way. I have a bucket that is full of gas. Looks empty, but you know, we can't see gas, can we? We can't see the air that we breathe. We can't really see gas. So if I take this water balloon right here and I drop it out here in the air, it sinks because I blew this up with my breath. So the air in my breath is heavier than the air around us, so it just falls in. So what do you think? If I put this balloon in this bucket, do you think it's gonna sink just like it did out here? Or do you think something else is gonna happen? Let's find out. So I'm gonna go ahead and take this off. Here we go. In 3, 2, 1, and it floats. Because there's some air in here, but there is also another gas called sulfur hexafluoride. Now that gas is 6 times heavier than air. So my balloon just floats right on top, and when I try to bounce it in, it just comes right back out. Boop. Just like that. And then it runs away. So, we have learned so much about solids, liquids, and gases. So make sure that you come back to this channel every day at 10:30 and at 3 for more exclusive science content right here at Curiosity Corner Live. Until next time, stay curious.